and welcome to Cooking with Physics. I'm Molly and this is Lydia. Thanks for joining us today.
Today, we will be making Rice Krispie treats and explaining the physics behind each step.
First, let's review our ingredients. We have butter, marshmallows, and Rice Krispies. All of these are an example of inertia, also known as Newton's first law. An object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by unbalanced forces. Because the vertical forces, gravity and normal, are balanced, there are no horizontal forces and the objects are not moving.
Wow, those marshmallows look good. We should probably taste them. Observe as Molly tries to catch one in her mouth. Wow! Great job, Molly! As this marshmallow was being thrown, it was called a projectile. Projectiles can be used to find information about velocity, acceleration, displacement, and the forces acting upon them. Let's see if Molly can catch this. Good try, Molly.
Thanks,
Comparing
Lydia.
these two can relate to Newton's second law. When the force was great and the marshmallow, also known as the mass, was small, the acceleration was also great. When the force was smaller and the mass, or the bag of marshmallows, was great, the acceleration was also smaller. These are two different examples of the idea that acceleration equals net force divided by mass, one with a smaller mass and one with a larger mass. Lastly, the marshmallow being thrown is an example of acceleration. The acceleration increased while traveling in the positive direction and decreased while traveling in the negative direction, which meant it had a constant negative acceleration. If we were to make an acceleration versus time graph, it would be a straight, slanted line with a negative slope.
Now it's time to measure the ingredients. First, we will measure out 3 cups of Rice Krispies into this bowl. Here, you can pour it. No, wait, I'm gonna pour it. Wait a second, we just showed an example of work. Work is defined as a transfer of energy. When I pushed the bowl, I exerted the force onto the bowl to make it move. The force I exerted caused displacement of the bowl. When I pulled the bowl back, I exerted an opposite force, which also led to displacement of the bowl. See how the bowl is not falling through the counter or floating? That's because of Newton's third law, in which the opposite forces acting upon it are equal. The gravity force on the bowl from the ground and the normal force on the bowl from the table are balanced. These are an example of Newton's third law pair. Great! Let's measure the marshmallows.
Time to mix the ingredients together. Good thing the butter is already melted. Now let's add the marshmallows.
You know what would be fun? Throwing the marshmallows in.
Yeah, you know what you just did, Molly? You showed examples of projectiles, potential and kinetic energy.
Really? How?
Well, when the marshmallow was resting in your hand, it was an example of potential energy. Potential energy is stored energy, or the object's ability to do work according to its position. When you threw the marshmallow, it became a projectile. We could make a velocity versus time graph, acceleration versus time graph, or a force diagram to get a better understanding of the object. As the marshmallow was in the air, it was an example of kinetic energy, or energy an object has because of its motion, that occurred because of the original force exerted on it. Let's drop the rest of the marshmallows in.
Okay, when we drop the marshmallows in, they are basically traveling at a constant acceleration of -10 meters per second squared because air resistance is negligent. Acceleration is defined as the rate that velocity of an object is changing. As long as there are no forces acting upon an object besides gravity, all objects will fall with an acceleration of -10 meters per second squared. The drop also showed another example of kinetic and potential energy. When the marshmallow was in your hand, it contained potential energy because of its position. When the marshmallow was falling, it contained kinetic energy because of the force of gravity.
And that'll make it Now let's stir everything together. Go back to me and I'll make.
Now let's put everything in the pan.
Yum. Notice how the pan is not moving at all? The pan is at rest, and as long as no unbalanced forces act upon it, it will stay at rest. That's Newton's first law again. Newton's third law is also displayed here. The Newton's third law pair that is being shown is the gravity on the pan from the earth, and the opposite but equal normal force on the pan from the earth.
Yummy, can't wait to eat them.